Now let's write the JavaScript based implementation of jump searching algorithm. Let's create a new file called jumpsearch.js. Okay, let's define a class jump search. Inside here, let's define a function called jump search. It will basically take array and the value that user wants to search. Now, as part of the first step, what we need to do, we need to define the block size. How will we define the block size? Let's say const block size equal to, block size is the square root of the length of the array, right? So for that, let's say math dot square root of arr dot length. Okay, this can actually give the floating point result. So to make it an actual whole number, what we will do, math dot floor of this one. Okay, math dot square root will actually give the floating point values in the result. In the arrays, we have a valid whole numbers as indexes, right? So to get that whole number, we are simply flooring whatever the result we got. Now let's define another variable called last index. This will be the last index in the block, which is nothing but the block size minus 1 in the beginning. Now what we need to do, we need to move this last index to the last index in the valid block of the array. To do so, what we will do, we'll simply run a loop while this last index is less than array dot length, and whatever the value we have at this last index is less than the value that user has passed. That means the value is still on the right side. That means that we need to move on to the next block. In that case, we will update the last index to last index plus block size, so that this last index will be updated to the next block's last index. Okay, once we have completed running this logic, right, we would have reached a point in the valid actual scenario. We would have reached a point where this last index would contain the value of the valid array blocks, the last index. Now what we have to do, we have to start at the beginning of that specific array block, and we have to run either binary search or linear search on that specific block, and we need to check if the value that user has passed is available. So to do so, what we will do, let's define a variable called current index, and this current index should start from the block's starting point, which is nothing but the last index minus block size plus 1. Okay, now as long as this current index is less than or equal to the last index, because from the beginning of the block till the last index in that block we need to search, right? That's why this less than or equal to, and this current index is less than the length of the array. And in that case, what we will do, we will compare each and every value at each and every index with the value that user has passed. That is nothing but array of current index. If it is equal to the value that user has passed, we will simply return the current index value, which is holding the value that user wants us to search. If this is not the case, we need to move on to the next index, right? So we will move on to the next index by simply incrementing current index by 1. Okay, using this is the linear searching algorithm, right? Using this, we have searched each and every index in the valid block of the array for the value that user has passed. If it is not available, we simply need to return minus 1 here. Okay, once again I'm mentioning this is a linear searching based implementation. If you want to apply binary searching also, you can go ahead and apply the binary search on the block of the array that we have got. Okay, let's just create a array and pass these values to this function that we have written and validate the result. And I'm passing some sorted values here because jump search requires the value arrays to be sorted, and the value that I want to search is, let's say, 6. Okay, let's simply create an object of jump search equal to new jump search, and js.jumpSearch, let's pass array and value. Okay, and whatever the result it is going to return, let's store it in index variable, and let's simply console.log index. Okay, now if we need to run it, node, this file is inside the searching folder, and we need to run jumpsearch.js. Okay, if you see, 6 is available at index 5, so we got 5. Okay, again let's say that I want to search for the value 1 itself. If I do that, node, see the output we've got is 0, which contains the value of 1. Let's say I want to search for -1, which is not available in the array. I should get -1, so, which I have got. Similarly, if we give any value that is larger than the larger value in the array, which is 11, I've passed, I've got -1. Okay, so we have implemented the jump searching algorithm using JavaScript successfully. So what we exactly did, we assumed a block of array of constant size, unlike exponential searching algorithm, and we tried moving it to the last index of that particular block, which could possibly contain the value that user has asked for. We started searching for the value from the beginning of that block till the end of the block, either by using linear searching or binary searching algorithm, and we have obtained the index at which that value is available. Otherwise, -1 is being returned. Okay.